Linear models and point slope form. So today we're going to be using linear functions to model real world scenarios. So we're going to be doing a lot of problem solving with what we know about our linear functions so far. So our first task for today, Mitchell uses an older digital camera that he got at a thrift store. Each picture takes 3 megabytes MB of space on a memory card. If S represents the amount of space left on the memory card, so S is the amount of space left on the memory card, and P represents the number of pictures taken. Then the amount of space remaining on the card can be modeled by this function right here. S of P equals negative 3P plus 498. So this tells me my input here is the P, which is the number of pictures taken. I put it into this function rule right here. So I take negative 3 times the number of pictures I've taken and add it to 498. The output is the space remaining on the card. How much space do I have left? Okay, so Mitchell takes a few pictures and keeps track of the available space in a table. He then draws a line through the points to model the relationship. Okay, so one thing to note is, so here we have a table, here we have our pictures taken, and then here's the available amount of space. So as we take pictures, the amount of space goes down. The more pictures we take, the less space we have on our card, which makes sense. Like the more photos you have in your phone, the less space you have on your phone. Okay, one thing to note is this is technically discrete. This would technically be a discrete function. Okay, so technically we should just have dots at each of these, so forth and so on. Okay, but to help us model the data and to draw conclusions from the data, we connect the dots to be able to see what's going to happen. So yes, that doesn't mean that I can take, like, I can't have an input of half a picture. Okay, not possible. You take 1 picture, 2 pictures, 3 pictures. I can't have halves. But we draw the graph in such a way that it looks like we can, just to help us model what's happening. Okay, so it is a discrete function, but we're going to draw it continuous to make predictions from it. Okay, so here he graphed these points. He put in a 0, a 10, a 20, and a 30. So he found S of 10. So I put a 10 up here into this function. So I take negative 3 times 10 plus 498, and that's where we got the 468. Okay, so we did that for each of those and got those outputs. So now we want to say, what does S of 0 represent in this context? What does S of 0 represent in this context? So S of 0, so this means 0 is the number of pictures. That's the input. That's the input, number of pictures. So what S of 0 represents, S of 0 is the amount of space, the available space on the memory card with no pictures on it. So it's really the amount of space on the memory card when you bought it. Like before you put any pictures or anything on it, fresh from the store, it had 498 megabytes. It was probably sold as a 500, but there's normally always a couple megabytes that are used for informational type data on them. So a 500 megabyte storage doesn't mean you get full 500 megabytes. It's pretty close. In this case, it's 498. So S sub 0 is the available space on the memory card with no pictures. So how does this value appear in the table? So it's going to appear as that 0, that 498. It's going to be an input of 0. So since my input is 0 and my input is my left and right, it's going to show up on the graph as my y-intercept. Okay, so it's a y-intercept on the graph. Okay, and what about, how does it appear in the table? It appears as the point 0. It appears like that in the table. It appears as the point 0, 498 in the table. Okay. What does the slope of -3 represent in this context? Okay. So to always help me figure out what slope represents, I always make sure this was the rise over the run. And it came from y equals, again, my linear function, f of x equals mx plus b. So we just pulled that m value off of here. It's the thing multiplied by my variable, my -3. So slope is rise over run. My rise, again, is the up and down. The up and down, in this case, is available storage space. So the rise is the megabytes, or the available storage space. I'm going to abbreviate here. Oop. Over the run is the left and right, which is the pictures taken. So it's a rate, megabytes per picture taken. And since it's going down, I know it's going down because it's negative. This tells me that every picture takes 3 megabytes of space. So basically, I lose 3 megabytes of space per picture. Every picture is going to reduce the amount of storage I have on there. So I lose 3 megabytes of space per picture. How does this appear in the table and on the graph? Well, on the graph, we already have it. On the graph, it's the rise over the run. In the table, my y goes down 3 for every down 1 in my pictures taken. Okay, so that's how it's going to show up in the table. And really, in the table, it's more so going to show up as we actually go down 30 for every down 10, because each one of these goes down by 10, up by 10, sorry, up by 10, not down by 10. Each one of these goes up by 10, up by 10, up by 10, up by 10, and these go down by 30 each time. Okay. Okay. Is the function s increasing or decreasing? Well, as I'm looking, it's going down. These values are going down as these values go up, so it is decreasing. How does this make sense in terms of the context? The more pictures you take, the less available space on the memory card. What does a 0 of the function represent in this context? Again, remember, a 0 is an input value that makes an output value of 0. So I want an input value. So input, again, was the number of pictures. The output is the available memory. So if I want the available memory to be 0, basically the 0 of this function represents the maximum number of, or the number of pictures. Let's not use the word maximum. We can, but it's a 0 would be the number of pictures that takes up all the available memory. Okay, so really it also is the maximum number of pictures you can take with this memory card. Okay, is that 0. So the input, the 0, would be the max number of pictures. Because your memory can't go into the negatives. After clearing the memory, Mitchell changes the settings on the camera to obtain a higher resolution. Each high resolution picture takes 8 megabytes of space. The last one, each picture took 3 megabytes of space. This one takes 8. because again, it's a higher resolution, more higher def pictures. Consider a function S sub h. We read this as S sub h that models the relationship between the amount of storage space in megabytes and the number of high resolution pictures taken. What does the input and output of S of h represent? Again, my input is still going to be the number of pictures, the number of high res pictures. And the output is going to be the available memory. How does this compare? It's the same. It's the same as the previous. Same as S, except they're high-res pictures. Okay. How would the slope of the graph of S of h compare to the slope of the graph of S? Okay, well, this goes down by 3 each picture. The next one's going to go down by 8. So the slope is going to be steeper, but still negative. Okay, so the slope of S of h, S sub h will have a steeper slope, but still negative. How would the intercepts of the graphs of the function S of h compare to the intercepts of the graph of function S? Well, we're still using the exact same memory guard, so this y-intercept is still going to be the same. But since each picture takes more data, my x-intercept is going to be smaller. So the y-intercept is going to be the same. Y-intercept will be the same. Since it's still 498 megabytes with no pictures. With no pics. Okay. X-intercept will be smaller. Will be smaller than S. Since slope is steeper. Okay. Sketch the graph of the function S of h. Write a rule for S of h. So we actually want to write the rule now. Okay. Well, to sketch a graph, again, this only makes sense for this to be positives. We can't go into the negatives for number of pictures. I think I'm going to use a similar scale to here. It looks like we're counting by 50s. Okay, so we'll go 50, there's 100, 200, 3, 4, 5, there's 500. So we still have that starting out point of 498. But now we need to go down 8 each time. Okay, so we can go ahead and create a table, S sub h of x. So at 0, we're still at 498. We need to go down 8 each time. So 10, I would go down 8 times 10 from that 498. So I would go down 80. So, 498 minus 80 will put me at 418. So at 10, let's see, we counted by 50 on that scale too. Okay, by 50 on this scale too. So at 10, we'd be at 418. So it's going to go down a whole lot steeper. Okay, we probably really don't want to include this stuff down here. We just need to figure out what this point is to help us out there a bit. Again, I just kind of sketched. We would need to, because again, it says sketch a graph, but we want to write a rule, which we already kind of did. S of h of p. Oh, sorry, I shouldn't have been using x's for this. This was p's. P is my input. S of h of p is going to be negative 8p plus 498. I'm going to find the 0, so I'm going to set this equal to 0 to help me find this spot down here. Okay, so we subtract the 498, negative 8p equals negative 498. So take 498 divided by 8. We get 62. Okay, so I can take a maximum of 62 pictures. So this would be the point 62.25 would be the 0. Again, 0.25 doesn't make sense in this context. I could take 62 pictures. I couldn't quite take 63. There wouldn't be enough available space for one more. Okay, so to help me find that 0, which if we're counting by 50s, that's pretty close. I was a little too far over. Okay, but there's my rule right there. We wanted a rule. There it is, because we're going down 8 instead of down 3. Really, that's the only thing that's changed in that one. Okay, next task. Task 2. Here we have Jim. Jim has a long drive home from a conference. He notes that his odometer, the thing that tells him how many miles is on his car, reads 1,500 miles at the beginning of his journey. So at time 0, 1,500 miles. Jim reaches home after 4 hours of driving. How can you model the mileage in his odometer as a function of driving time? Graph the function and identify any minimum or maximum values. Well, over here in the picture, we know his speed is 50 miles an hour. So that tells me every hour, I'm going to create a table out of this. For every hour, he goes 50 miles. So 1 hour would be 50 miles farther than where he's at, which would be 1,550. 2 hours would be 50 miles more than that, 1,600. Okay, so we're starting with our 1,500, and here we took that 1,500 and we added 150. Here we took this 1,500 and we add 250, so 50 times 2, and this is 50 times 1. So 3, we would take 1,500 and add 50 times 3. Do you kind of see how this function's playing out? Okay. So first of all, a negative in this case also does not make sense. We're going to sketch the graph. Over here, I'm going to have every 2 be 1 hour because my graph is pretty tiny. And I only need to go over to 4 hours. And my original mileage is 1,500. So I think I'm going to go, and it's only going up. So I think here we'll go 500. We'll have every 2 be 500. So there's 1,000. So here would be 1,500. And then we would have 16. Nope. Or, I have a better idea. Let's have this graph skip. Let's put a skip in it. So I'm going to do a zigzaggy line there, and we're going to start here at 1,500, and we'll go up by 100. So 1,600 every 2, 1,700, 1,800. So at point 0, we're at 1,500 miles. So if you're not familiar, when we're skipping a chunk of graph, we do this little zigzaggy thing in the graph to show us that that part's not to scale. Okay. After 1 mile, we're at 1,550. 2 miles, we're at 1,600. 3 miles, we'd be at 1,650. 4 miles, 1,700. Okay, so there's our graph. Is this a linear function? Yes. How can I tell? It has a constant rate of change. It goes up by 50 each time. Constant rate of change. Okay. What does f of 0 represent? F of 0 would represent the mileage at time 0. Because that's my input. My input is the time. Mileage at time 0, or how many miles are on my car before I start. How does the slope help you sketch the graph? Well, we went up by 50 and over 1 each time. So how does it help us? It gives us the next point. Gives us the next point as we go. Okay. So we graph the function. It says first we should identify any minimum or maximum. My minimum, the minimum is 1,500 miles. My maximum, we only go up to 4 hours. The max is 1,700 miles. That's where we end. Is the function increasing or decreasing? It's increasing. Okay, longer you drive, the more miles are put on the car. What do the domain and range of f of t represent in this context? My domain, again, is the set of inputs. My inputs start at time 0. Okay, but this one, in fact, is not discrete. I can connect the dots because I can drive half a mile, I can do half a minute. So really my domain would be all the numbers from 0 to 4. Or I would write it this way: 0 is less than or equal to t, if we're time, less than or equal to 4. There's the domain. My range is the set of outputs. Well, my smallest output is 1500, and your min and max are a good indicator of your range. My minimum is 1500, my maximum is 1700, which tells me my range has to be in between there. F of t is less than or equal to 1700. What do they represent in the context of this? The domain represents the time driving. The range represents the miles on the car. How many miles did Jim drive? Well, he went from 1500 to 1700, so he drove 200 miles. Okay. All right. Okay. Next problem. So here we have a slope formula. Okay. We are going to take, this is our standard slope formula. Subtract the y, subtract the x's. The only thing is I don't have sub 2's on here. And it's okay, you don't really need them. We just need the sub 1's, just help us tell the difference between this y value and this y value. So if one of them has a sub 1 on it and the other one doesn't, we know they're different things. If I take this equation, this is my denominator, and I take both sides and multiply by that denominator, the x times x minus 1. X times x minus 1. Okay, these will divide to 1, and I'm left with y minus y1, m x minus x1. Okay. This is what we call the point slope form. The reason we call it that, first of all, that slope is still m, but we can use this to actually write the equation of a formula if I know the slope and a point on it. So the point x1, comma y1 is any point on the line. In other words, I do not need to know the y-intercept anymore. If I can remember point slope form, I do not need to know. You don't need B, that y-intercept. I can write the equation without it if I use this guy. Okay, so how that is used. So here we're going to go ahead and do task 2. A bald eagle is shown diving towards its prey. Its distance from the ground is decreasing, so that's going down, an average rate of 140 feet per second during the dive. Okay, so what is the rate of change in this context? This is it. It's going down, so it's going to be negative. That's the slope. The rate of change or slope is for every second. This is my rise, feet. This is my run, seconds. If I graph this, seconds would be here, height would be here in feet. Okay, if I'm graphing this, my rate of change is negative 140 feet per second. That is my slope. That's my m, is negative 140. Okay. So the next question is, what point t sub 1, h of t sub 1, meaning this is, I want an input value and its corresponding output value, can we determine from the given information? If I look here in this picture, it says at 0.7 seconds, I am 62 feet off the ground. We said our input is time. The output is height. I know a time and a height. I know at 0.7 seconds, my height is 62 feet. Let's put units on that. So I have a point, 0.7 and 62. So since I know the slope and a point, I can write an equation in point slope form. So the first thing I'm going to do, I didn't leave enough room for this, so we'll do it off to the side here, is take y, I'm going to write it down. Y minus y sub 1 equals m x minus x sub 1. I am going to plug the slope of negative 140 in here for slope. And then I'm going to plug 0.7 for an x, 62 for a y as my x sub 1, y sub 1. This y and this x are my input and output variables. Those stay there because my final equation should have an input and output. Okay, so let's go ahead and write this down. Y minus my y sub 1 is 62. Sorry, I know I'm jumping between colors, but it helps to color code it. My slope is negative 140. X minus my x sub 1 is 0.7. So there I've got my equation, but I'm going to rewrite this because I want to simplify it a bit. I can distribute this 140 in. So I have y minus 62. Oh, let's be in black. Y minus 62 equals negative 140x. A negative times a negative is positive. I need to take 140 times 0.7. 98 plus 98. Now we would add 62 to both sides. Y equals negative 140x plus 98 plus 62, 98 plus 62, 160. So now I have it in y equals mx plus b form. What is the bald eagle's initial height? Well, there it is. I've got it. 160 feet. It's the y-intercept. That's its height at time 0. Time 0, it's at 160. Okay, now this next one, I want you to do on your online textbook.